Hello, and welcome to this first edition of ARC's Industrial IoT Edge Insights podcast. This is Chantal Polsonetti, Vice President at ARC, and this podcast is the first in a series of periodic updates on the dynamic Industrial IoT Edge environment stemming from ARC's primary research into the topic. Now, from our perspective, the term Industrial IoT Edge really wasn't an issue until the advent of the Industrial IoT itself, let's say 5 or 6 years ago. So let's start with the definition of the IoT. ARC views the Industrial Internet of Things as a place where intelligent physical entities, such as sensors, devices, machines, assets, and other products, connect to each other, to Internet services, and to applications. The Industrial Internet of Things definition involves integration of sensors, assets, devices, etc. to enterprise clouds. Inherent in this is the use of IP-connected devices, typically Ethernet or Wi-Fi based. Now, drilling down into the definition of the Industrial IoT Edge itself, this has been a topic of much discussion both internally and externally with ARC analysts and a variety of supplier, end user, and solution provider customers. This is a dynamic entity which is evolving constantly with new developments. But the way we see it is that the Industrial IoT Edge is the place where physical devices, assets, machines, processes, and applications intersect with Internet-enabled portions of the architecture. Industrial IoT Edge devices themselves may provide input to and receive output from Industrial Internet-enabled systems, applications, and services, but they actually reside outside of clouds and data centers. A third critical component of our definition is that edge systems typically operate on-prem, but they're distinct from traditional non-internet connected automation and control systems. This last part of the definition, the distinction from traditional automation control systems, is an area where we've experienced some confusion, particularly in the early days amongst our customers. Many customers already have distributed control systems, although they may or may not be IP-based. But as we know, IP-based Ethernet continues to descend throughout the automation architecture. Another response to early IoT inquiries was, isn't this really just another MES layer where we just have to serve data up from our assets at the OT tier, provided to the applications in the enterprise cloud, and then they'll leave me alone? So these two aspects, the pre-existing MES layer and the existence of distributed control systems, in our experience, led to some confusion on the part of our customers once of the advent of the Industrial IoT itself. On the other side of the equation, a lot of our IT supplier and user customers basically saw an on-site data center as an edge device or an edge asset coming from their perspective from the top down of the architecture. From ARC's perspective, we see the Industrial IoT Edge ecosystem as much more nuanced and richer than any of this MES or network infrastructure layer, or even in traditional sites of IT-OT convergence. The edge tier instead currently represents a wide, really broadening functional spectrum, ranging from connected devices and converting automation protocols, so the data can be consumed by higher levels of the architecture, to developing, deploying, managing, visualizing, and even executing applications critical to achieving business improvement and competitive advantage. Of course, inherent in this is the convergence of not only the traditional IT and OT technologies, but also compute connect capabilities within the Industrial IoT Edge itself. Discussions of IT-OT convergence within the industrial networking realm typically focus on migration of IT technology into the OT or automation and control domain. We've certainly seen this in the extension of standard Ethernet networks and standard operating systems like Linux and Windows into industrial automation architectures. These are really some of the most prominent examples of this convergence. In recent years, and with the advent of the IoT, as well as Industry 4.0 and associated concepts, this has really extended the definition of IT-OT convergence to the merging of computational power and connectivity, or compute-connect convergence. Now, in terms of the edge ecosystem, this convergence is particularly apparent within the industrial network infrastructure tier for now, but something that we think is going to migrate even further down to the endpoint, as we will discuss in subsequent episodes. So network devices whose primary traditional role has been to enable data connectivity between and within the different layers of the architecture are now adding compute power to meet the ongoing demands of edge computing. At the same time, the need to process and deliver pre-processed OT data to those cloud-based enterprise applications is driving compute capability down in the architecture and closer to and onto the industrial IoT edge. Suppliers are responding to this expanding range at the industrial IoT edge by expanding the range of hardware, software, and solutions and services targeted to servicing this broadening functional spectrum. So if you take a traditional automation gateway that used to be used for simple protocol conversion, and legacy control devices typically used for logic, process, or motion control, well, these devices at these two tiers, the endpoint tier and the infrastructure tier, are now morphing into edge computing devices that support standard processors, such as those from Intel or ARM, and COTS-based operating systems, particularly Linux, as well as containers where edge computing applications can be executed. And then at the same time, a new thick edge tier populated with high-end edge servers that reside on-site is emerging to serve the escalating edge compute and storage requirements. And at this tier, we see the thick edge storage requirements being forged above the network infrastructure layer, or the thin edge. We'll talk about this tiering more in a subsequent episode. On the software side, there's a similar evolution taking place. Industrial IoT edge platforms have emerged from their origins in things like device connectivity, visualization, and device management to full-blown IT/OT or integration and application execution environments capable of serving these escalating requirements that we've been talking about at this tier of the architecture. Now, industrial IoT edge software platforms are increasingly viewed as the vehicles for both local computation and application execution in service to industrial IoT-enabled business improvement processes. We'll have several subsequent episodes related to this emerging topic. I hope this information will be useful on your journey to understand the evolution of the industrial IoT edge. As I mentioned, this is the first in a series of podcast episodes from ARC Advisory Group dedicated to this topic. In the future episodes, we'll be detailing our findings as they relate to developments at the industrial Internet of Things edge. Look for further episodes coming soon. In the interim, please check out our Industrial IoT Edge page on arcweb.com. Thank you.